Hi, EK210. Today we're just going to give you a few tips on using your reverse engineering projects to help you out with your forward engineering project. So first thing we'll talk about is packing devices. Like say if your group was tasked to make a humidifier, if you simply took a humidifier that you bought and rebranded it your name, right, and said here's my project, that's not acceptable. But if you take a small part of your reverse engineering project, like say one of the sub-assemblies out of the enclosure, you either to look at or you reverse engineered that and used the sensor, that's okay for the class. So we'll take the scale here as an example of that. So a lot of the groups reverse engineered a scale, and we learned from the scale that the main sensing element is what we call a strain gauge. Like this is the foot of the scale right here, the scale's upside down. So when you stand on the scale, you're putting a force into the foot. So this is the same type of foot right here. So you can see there's this metal plate right here, which is a spring. So if I push on the spring, you can look very closely. So the spring actually bends a little bit. And so as that's bending, there's a strain gauge that's sitting on top of it. It's bonded on top underneath this puddle of epoxy right there. The strain gauge bends and it changes resistance that appears on these wires here that goes to the processor. So in other words, if we looked at the physics of that, we have a graph right here where we're applying a force to the spring and then we're getting linear displacement out of the spring. So springs have a spring constant, it's usually a linear constant like that, and we call that slope K, meaning that for a given force, we're going to get a given displacement out of it, right? So a higher force will yield a higher displacement. Now, so that gives us displacement, but we still don't know how much we displaced. That's where the strain gauge comes in. So the strain gauge is going to take that displacement and it's going to convert it to a resistance. So the strain gauge doesn't start with a zero resistance. It starts with some base resistance value, and it's fairly linear over a certain extent. So that's saying that at zero displacement, we have some resistance. If we displaced our strain gauge by moving our spring that much, we'd get this much resistance. By this much, we'd get that much resistance. So you could see we could take force and map it to resistance by using the strain gauge. So this right here is the strain gauge close up. You can see this is the spring right here. The metal part is the spring. When the spring bends, this little piece right here, it has little electrodes on it, on some Kapton, that bends. And when that bends, that produces this change in resistance. So that bending, is a displacement. In other words, this part right here is bending with respect to these outer legs. And then that gets mapped as a resistance change on these three wires right here. So now if we wanted to use that on, say, something like, imagine you're building the testing machine for Gillette. So say if you wanted to measure strain or bending in a piece of metal, something like that, you could take a strain gauge. I don't actually have one, but I'm going to pretend this piece of tape is a strain gauge right here. So I bond my strain gauge to the material. It would have wires coming out of it. And then as we bend the material, it's going to change the displacement. It's going to stretch that strain gauge, and it generates a different voltage. And you could read that using something like an Arduino. So the block diagram of that would look something like this. Where you have your spring like that. We put the strain gauge on. Then there are wires that go off the strain gauge, and those go to an amplifier, which we could show you how to build. And then those might go to something like Arduino or a microcontroller. And then from there, you could get the data and import it by USB onto a laptop or something, and then you could analyze it. You might be counting strain or something. So that's one example of using some of the parts. Like you could just use this foot out of one of the scales, because we have probably 30 or 40 of these feet right now, or you could buy a strain gauge from a manufacturer. So that's up to you. If this one will work, that's good. It's unlikely that we'd be able to get that strain gauge off of here because it's epoxied on. So if this shape of spring doesn't work and the force doesn't work, then you'd probably want to buy a whole new strain gauge. So another example is the humidifier. There are a few projects that use humidifiers, such as this one over here. The safety first one. And if we take that apart, which Kyle did, and take the bottom off of it, then it looks something like this right here. So we know from the reverse engineering projects that the nebulizer, the part that makes the humidity, is this piezoelectric plate right there. So we could probably scavenge that part of the humidifier to make humidity for some of our projects. So when this thing is assembled, it looks something like this. And then we take the screws out, flip it over, and we have the nebulizer element right here. So if we could figure out some way to power this board so that it does what it did when it was in this device right here, then we could use this as a sub-assembly, which is okay to do, since it's not the main part of the project in order to generate humidity. So just looking at this in a little bit more depth, so the power comes in off the power cord. We don't really want to work with line voltage because it can be kind of dangerous. But this power supply probably generates 24 or 12 volts. So we could measure the voltage coming out of here, and we could either duplicate this using a low voltage supply, and then we could hack the controls on here. Like this one has the knob on here that gives us different humidity rates. It has the float sensor, and we could take all of those things and hack them and set this device up such that we could turn it on and off with something like an Arduino. Like instead of having a knob on here, we could either have a relay or a digital logic pin that sends a signal to the circuit board that'll tell this device to come on at a preset humidity and to go off when it exceeds that humidity. So that's okay to do. And so the key here is figuring out what the voltages are that it requires and what the signal is that would trigger it to go on and off.